condition for general equation in second degree to represent a circle. Now, the first question that comes to our mind is, how would a general equation in second degree look like? So, the general equation of second degree will have terms like ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. Now, let us call this our equation number 1. If we look at this equation closely, here in the first three terms, the degree is 2. For the next two terms, the degree is 1, and for the last term, which is a constant, the degree is 0. Now, if you have seen the videos before, you might have understood how do we write the general equation of a circle. The general equation of a circle is x square plus y square plus 2gx plus 2fy plus c equal to 0. Let us call this equation number 2. Now, in order that equation 1 represents a circle, it should have some similarity, or in other terms, it should look exactly like equation number 2. Now, so let us compare these two equations and figure out two conditions how and when the equation number 1 that we have will represent a circle. So, if we look at equation number 2 closely, we find that there is no term involving x and y. So, from here we get the first condition. Condition 1, coefficient of x square xy should be 0, which means h should be equal to 0. And now what next? Now let us look at the coefficient of x square and y square closely in equation number 2. Here we find that the coefficient of x square and y square are equal, and they are both equal to 1, which means from here we get another condition that in order that equation 1 represents a circle, the coefficient of the term ax square and by square should be equal. So, the second condition is coefficient of x square should be equal to coefficient of y square, which gives us a should be equal to b. So, these are two of the necessary and sufficient conditions for a general equation in 2 degree to represent a circle. Now, in order to have a better understanding, let us try a few questions. So, let us say we have a first question which says, find the center and radius of the circle which is represented by 2x square plus 2y square minus 8x minus 4y minus 40 is equal to 0. So, here let us first check whether this equation will represent a circle or not. So, for that we have to check two conditions. The first condition is the coefficient of xy should be equal to 0, which simply means there should be no term containing x and y. So, in this equation that we have, there is no term involving xy. So, we have the first condition is correct, satisfied for our circle here. Now, let us check the second condition. Now, which says the coefficient of x square and the coefficient of y square should be equal. Here again, if we see, then clearly the coefficient of x square and y square are equal, and they are equal to 2. So, let us try and now understand what will be the radius and center of this circle. So, the first step for that is, what we have to do here is we want to make the coefficient of x square equal to 1, because after that we know the simple formula that for this equation number 2, the center is given by, if we write the center for the circle which is represented by center of circle represented by equation 2, then we can easily write that as equal to minus g comma minus of f, and the radius will be equal to under root g square plus f square minus c. So let us try to use this formula to find the center and radius in this case. So in order to get this equation in the form of equation 2, we divide this equation by 2 on both sides. So on division we get x square plus y square minus 4x minus 2y minus 20 is equal to 0. So here if you look, 2g is equal to minus 4, 2f is equal to minus 2, and the constant c here is equal to minus 20, from which we get g is equal to minus 2, f is equal to minus 1, and c remains as minus 20. So the center is given by minus g comma minus f, which makes it 2 comma 1, and the radius is under root 2 square plus 1 square minus of minus 20, and that is equal to under root 2 square is 4 plus 1 plus 20, which makes it 25, hence the radius is 5. So we found that this equation represents a circle because it satisfies these two conditions, and the center and radius are 2 comma 1 and 5 respectively. Now let us look at another question which involves these two conditions. So you might come across a question which says, let us say this is our question 2, which says find the value of constants, find the value of alpha and beta if alpha minus 3 x square plus beta minus 4 x y plus y square minus 4x minus 2y minus 20 is equal to 0. So here we have an equation which is a general equation in 2 degree, and it is said that this equation represents a circle. If this equation represents a circle, so straight away we would go to the conditions that is given over here, and we'll try to find out the values of alpha and beta based on these two conditions. So our first condition says the coefficient of x and y, x into y, should be 0, which means there should be no term involving x and y, which means if we have to vanish or we have to eliminate this term, then the coefficient of x and y should be 0, which means beta minus 4 should be equal to 0, from where we get that beta is equal to 4. Now let us apply condition 2. The condition 2 says the coefficient of x square and the coefficient of y square should be equal, which means the coefficient of y square which is equal to 1 and the coefficient of x square which is equal to alpha minus beta should be same, which means, so this is the result from condition 1 and this is the result from condition 2. So from here we can write alpha minus 3 is equal to 1, which gives us again that alpha is equal to 3 plus 1 and that is 4. So here are the values of alpha and beta for this equation to represent a circle. Now clearly if you see, we have satisfied all the conditions, and if you want to calculate the center, clearly because alpha minus 3 is 1, so already the coefficient of x square and y square is 1, the center is again going to be nothing but minus of g, which will be equal to 2 comma 1, and the radius is again 5, because if you just check this equation and this equation becomes equal, becomes the same upon substitution of alpha and beta. So now I hope you have a fairly good understanding of when a general equation of degree 2 will represent a circle.